Hello everyone, welcome to another lecture of robotics and automation. In the previous lecture we studied about PLCs and their programming using ladder logic. In today's lecture we shall talk about industrial communication, how different components communicate between each other. For example, here you have a picture where it's shown an industrial system, automation system, and on the ground level here you have, as you can see, you have here sensor, valves and actuators. So these are all some kind of solenoid valves, and then you have some kind of displays or controllers, and then you have here some sensors. For example, this is a proximity sensor, and they are all used to collect either data from the environment or either to do some actuation to perform some task. And they are connected using CAN bus. So CAN bus is a protocol, it's a method of communication between devices, and later we shall study about this protocol. So these sensors, for example, this proximity sensor, this is actually IR sensor. This is connected with CAN bus to the some other actuator, and then they are also connected to embedded controller. And in this embedded controller can also be replaced by, you can replace by its a PLC. You can replace here either a microcontroller, embedded controller, or a PLC also. And then this embedded controller is connected to the control station and other controllers via Ethernet. So Ethernet is another method of communication between devices, and so at this level, and all the components, they are connected using the Ethernet. And then you have a router here, and this router, it connects your factory network, which is available in, so these all components, this PC including these embedded controllers and sensor actuators, they are in the factory network here. Okay, they are in the factory, and this factory network is connected to the router, which is again connected to your office network, where your boss and the management people, they sit there. So they have their own personal computers, and there they can monitor the process, the automation process, and they can also maybe when necessary they can offer some commands for changes. So yeah, so as you see that where you have the monitoring is required, you use these computers with Ethernet, and where you have real-time control is required, then you use either embedded controllers or maybe PLCs with CAN bus or some other kind of protocols. So this is how the devices communicate with each other efficiently. This is not the only way, I would say. This is not the only way that communication can happen. This bus, for example, the CAN bus can be replaced with some other protocol, and we already discussed this. Embedded controller can be replaced by a PLC. Yeah, so there are many different various techniques that you can use for communication. So this is one example. So if we use here let's say a PLC have actually, for communication, it has a Ethernet port. So I'm not sure whether all of them have, but many they have Ethernet port, and here you can connect a PLC, and you can connect via this PLC, you can connect it to the another PLC, let's say PLC 2. So you can do this connection with another PLC. And via this Ethernet port, then you can do communication between them. And this PLC has some input and output ports, and then you can connect some actuators, for example this solenoid valve to the output port of the PLC, and if you have some sensors, for example, then you can connect them to the input of the PLC. So this PLC, it can be from, there are different companies for PLC, for example Siemens, Allen Bradley, and many other you will find. So basically PLC also have serial ports. If you remember the previous diagram, we talked about this serial port here, and this serial port can also be, there are actually two of them, and they can also be used to communication between another PLC or maybe some other computer. So they can be used for communication, this serial port also. Actually there are two serial ports. And there it can also be used for programming. If you connect them with a computer using a programming device, then you can also use for programming. And then you have some outputs where you connect your actuators, and then you have inputs where you have some push buttons. This is normally open push button. Then you have a limit switch. So push button is like something you push, and here you have some kind of spring. Okay, so it will keep closed as long as you push it. When you stop pushing it, it will go back. So it has some kind of spring here. Okay, some kind of spring here attached. But this limit switch, it is like a normal switch. Once you close it, it will remain closed. Once you open it, it will remain open. So this is normally closed push button. This is normally closed limit switch. This is normally open limit switch. And they are all connected to inputs. Okay, now let's dig into some basics of communication. And first we need to define what is data. Data refers to a collection of numbers, characters, and is a relative term. Data is collected and analyzed to create information suitable for making decisions. So it's a collection of numbers, characters, and any other related terms. And what it is being used is to analyze some suitable, it is used to create some suitable information, and the end goal is to make decisions based upon this data. Okay, now what is communication? Communication is the activity for exchanging information and meaning across space and time using various technical or natural means, whichever is achievable or preferred. Communication requires a sender, a message, a medium, and a recipient. So for communication you need these four things. Although the receiver does not have to be present or aware of the sender's intent to communicate at the time of communication. Thus, communication can occur across vast distances in time and space. So I think this figure will better explain. So we already studied we need sender, a message, medium, and recipient for communication. So here you have a source, and then you have a transmitter, and then you have a transmission system, receiver, and destination. So we can divide it as a source system and destination system. Okay. So this was a general block diagram, but if you want to realize in a physical terms, then you have, let's say, a computer which is connected to modem, and this will be your source, and then modem will be a transmitter. And then you need actually a network, some kind of physical medium to transmit your message. Okay, so this will be your transmission system, and then you again need a receiver that receives your message, and then finally your destination, or you can also say a recipient. Okay, so defining these terms, source is this is a device. This device generates the data to be transmitted. Examples are telephones and personal computers. So where you generate the data to transmit. Transmitters transforms and encodes the information in such a way as to produce electromagnetic signals that can be transmitted across some sort of transmission system. Like modem is a good example. Transmission system. This can be a single transmission line or a complex network connecting source and destination. So either it can be a single telephone cable or optical fiber cable, or it can be a whole network of, let's say, either wireless, you can say wireless data transmission systems, or maybe wired local area network. Then you have receiver. The receiver accepts a signal from the transmission system and converts it into form of that can be handled by destination device. Again, you need some kind of conversion, okay, because the data that is being transmitted, it might be encoded so others cannot read it, so you need some kind of device to convert it back. Then finally, the destination takes the incoming data from the receiver, and then your message is delivered. So yeah, so this was all about communication, and let's see how in what formats we can actually transmit our data. We can transmit data in either analog format or in digital format. So this is example of a data in analog format. As you can see, it is continuous, okay. And the example of in real world, you can say when you like radio and TV, FM, AM, so they are all analog transmissions. This is all about analog transmissions, because what happens is that when you transmit they transmit the data from the antenna from the radio station, so it is being either frequency modulated or amplitude modulated, okay, but it is some kind of continuous signal. It's not digital. But if you there is another method also which is very successful nowadays, and this is actually the digital method for data transmission. So in here data is actually converted into discrete bits. Either they can be 0 or 1, or you can say they are 0 volt or 5 volt. And the best example is the like you have local area network, okay, you have Ethernet. So these are the examples. For example, the cables that you directly connect to your computer, there you have the communication between router or modem. So they are all actually digital. They're communicating with your computer digitally. So now communication can be it can be categorized into simplex, half duplex, or full duplex. So there are three types of communication we can categorize. So in simplex communication or transmission, you have unidirectional data flow. Okay, so if so the data, let's say this is a source and this is the destination here, so data will only flow in this direction. Okay, so this will be your sender and this will be your receiver. So let me write it down here. So sender and receiver, the data flow will be in only one direction. It will be unidirectional. So this is called simplex. Then we have half duplex, where the transmission of data is alternate bidirectional. It means that at a time there will be only one directional flow, but alternatively it can be reversed. So it's for example, first this one is the, let's say this one is sender of data, and this one is sender and this one is receiver. Okay, and then this one is sender and this one is receiver. So first, if the communication is in this direction, so this one will be sender and data will flow from here to here. Okay, and meanwhile this is not allowed to, this sender is not allowed to send data. Okay, the data can only go in this direction, and once the data transmission is completed, then this one is allowed to now transmit data from the other direction, and here the data will be received. So this is half duplex. And the third one is the full duplex transmission, in which simultaneously there is a two-way transmission of the data. For example, this is the sender and this is the receiver, and this is sender, here we have receiver. So this will be sending data from here to here, and this will be sending data from here to here. So simultaneously data is transmitting and receiving from both sides in both directions. Okay, so communication can also be categorized into another type, which is the serial and parallel communication. So serial transmission or serial communication, the link usually requires 3 wires: send, receive, and earth. The bits in a byte are transmitted one after the other. So in serial communication you have one is the sending wire, one is the receiving wire, and the other one is ground wire that we don't show here. So how the data is transmitted is that you have a sender and here you have receiver, here you have sender, and here receiver. So data flows like this from in a serial communication, but sequentially. Okay, for example, if you want to send like 0 0 1 0 1 1, so you have to first send 1, then 0, then this was 0, then so sequentially you have to bit by bit you have to send data in this serial communication. But in parallel communication, the bits in the byte are transmitted simultaneously, used for short distances, as each channel tends to cause interference on neighboring channels. The quality of the signal deteriorates rapidly. So in parallel communication you have multiple wires, and you send your data in from sender to receiver. You send like 0 1 0 0, so in a parallel fashion at the same time. Okay, so the next is the synchronous serial transmission. So in synchronous serial transmission, data is transmitted continuously. A synchronization signal is transmitted in parallel with the data signals. So synchronization is actually when both sides, they are on a same page, you can say. Okay, they are mimic, so they are like behaving in a similar fashion, you can say. So this is called synchronous serial communication. But on the other hand, if we have asynchronous serial communication, data can be transmitted in an irregular fashion, although the interval between two bits is fixed. Synchronization bits start, stop, encapsulate the data. So what happens is that in synchronous transmission of data, you don't need actually a clock. Okay, from the sender to receiver, sorry, in synchronous serial transmission you need actually a clock. So both clocks, the one at the sender and at the receiver, so both clocks are synchronized. It means they have the same time. And so when the data transmission happens between the 2 points from sender to receiver, so it happens at the same time. Okay, so that's why it's called synchronized data transmission. And this is very useful, especially where you have a real-time control, or where you have to like control things in real time. For example, if you want to control the let's say a stepper motor, so there you need actually, or let's say if you want to get some real-time feedback of water level in a tank, then you need some kind of synchronous, really without delay, some kind of communication. And for that synchronous serial communication, it will be good. So you have clocks here, clock 1 and clock 2, and they both are synchronized, and then data transmission happens in a serial manner, and there is no start or stop. It happens just at the same synchronized time the data transfer happens. But in the asynchronous serial transmission, the sender and receiver, they don't have any clocks. Okay, so what happens is that first it sends like a start bit, it sends a start signal, okay, to the receiver, and then goes the data, and then goes the stop signal. So 1, 2, 3. So this is the this is how the asynchronous serial transmission works. So now we have studied many different types of communication methods: parallel, we have studied analog, digital, half duplex, full duplex, serial, synchronous, asynchronous. So which one is best? So again, it depends upon different factors, or which one is the better choice. It depends upon what kind of wires you have, or the communication medium you have, how much cost you are going to pay, the speed of the transmission that is required, and whether you need a real-time control or not real-time transmission. So, but for the reasons of cost and durability, so these, if we consider these two factors, most communication networks use half duplex asynchronous serial digital transmission. So this is the most commonly used, because cost is a very important factor. They try to reduce the number of wires, and because half duplex, you can use less wires, and just by switching, using some protocol of switching, you can actually, using same less wires, you can perform same task as you can do with the full duplex with double amount of wires. And yeah, so serial communication all again saves wires, okay. And asynchronous, if we use asynchronous, it's like we don't need to bother about having clocks, okay. We don't need these clock things, and things will get you, it will be much, I will say, easier. And so that's why you see most of the communications when you connect your, for example, your printer or even your local area network. So most of communication is happening using this half duplex asynchronous serial digital transmission. Okay, so quickly moving forward, we have communication requirements. So what are the requirements of communication? So if you look at this figure here, you will see that in any company, in any automation system, you have actually these some levels of hierarchy, where you have sensor level communication, and then you have machine level communication, and then you have workshop level or management, and then finally a company level. So these are 4 levels of communication, and each of these level, okay, they have their own requirement for speed and the amount of data. So component level, control system level, production management supervision level, and information system level. So you see that if we look at the required speed of a reaction, so you see that at the sensor actuator level, or level 0, we need a very quick response. We need actually like a response time of 1 milliseconds. But as we move upward, okay, the response times actually increases. So there is more delay sometimes. For example, at production management level, there can be a reaction time can be of in seconds, so there can be a delay of 1 second. So nobody is going to bother if a supervisor gets a signal after 1 second, so it's not a big deal, okay. And similarly, the going up one level up, the management level, who have like more big picture, who want to see the big picture of production, they can tolerate a delay of even 1 minute also. But on the other hand, if we look at the amount of data to be transmitted, it's actually opposite. For the information system level 3, we have data of megabytes, and then going down you have then kilobytes data, and for component level or sensor actuator level 0, we have bits of data. So it means at lower level we have less data, but we need very quick reaction time. But on the higher top level we have more data, but the reaction time is also slower. Okay, so I have deleted the picture here because it was in the upcoming lecture we shall discuss those communication protocols in detail. So let's move toward the communication tasks. So what are the tasks of communication? The first one is that transmission system utilization. So whatever your communication protocol is, it must be able to utilize the communication system, either, for example, if it's a wired network or if it's a wireless network. So your protocol, your communication system should be able to recognize this network and also be able to use this network efficiently. Okay, and the second is the addressing. Of course, we have here, for example, this is the let's say we have this is let's say person 1, person 2, person 3. So we have 3 different devices, or okay, let's not call them persons, we can call them devices. So this is device 1, device 2, device 3, and so for example, if they want to communicate, you have here some kind of transmission system. It can be a router, it can be a modem, or simply a switch. So what here is that each device have its own address here. Okay, so your communication protocol or communication system must be solve the problem the problem of addressing these devices. Okay, so if it has to send data to, for example, device 3, so it must know the address, and then it should be able to route the package to this address. Routing is, again, this is about finding the route to the, so that your package, your data is transmitted to the desired device. So routing is about finding the efficient path. Okay, this is very simple network, but if it's a very big network, so there can be multiple routes or paths, and you have to find out which is the fastest and which is the efficient method to transfer your data from one device to another device. Synchronization, this happens in synchronous communication or synchronous data transmission. So in synchronous data transmission, you have, as we already studied, that the clocks must be ticking at the same with the same time. Okay, so that data that is being transmitted should be able to receive by the receiver at the same time without any delay or without any. So this synchronization is also the task of our communication system. Message formatting, you have to format your message so that it follows certain rules and regulations, and also standards, and it must be also be understandable by the receiver. So you have to format your message in such a way that it's understandable by the receiver. And then you have exchange management. This is about when you're exchanging some data. For example, you're exchanging some messages about to confirm that whether the device is ready to communicate or not. So you can use this. So this is also important because getting to know that whether the other device is ready or not, this is also important. And then you have security, error detection and correction. So I think these are the two of the points. So first one is the security. In security, what we do is we have to encode. This is about encryption. Or encoding. Encryption or encoding of data, so that a third person or a third device cannot easily read your data and cannot steal the information. Error detection and correction. So it happens sometimes because it may happen that when you send something from one device to another device, it may get lost somewhere. It may, because of the maybe damaged cable or maybe a faulty routing scheme, it may get lost. Or so you also need some kind of error detection that this data is not valid, and also there should be also need to correct this data if possible. So for these purposes, we use these collision detection and also some checksum bits. We add with the data some of the bits to make sure that your whole data is valid, it's not corrupt, and there is no error in the communication. So this is also a task of your communication device, to make sure that there is error detection and correction mechanism. Then you have network management. This is about in the network how many devices you have connected, what is the topology of this network. I mean, how the devices are connected to each other and what type of wires are being used. Is it wireless or wired communication? So everything about the network and the devices in the network is also the responsibility of your communication protocol. And then flow control. In flow control, it's about more about who will talk at what time. Okay, for example, in a group of people, when everyone is talking, then nobody will understand. Okay, so in this example, for example, if device 1 and device 3, they both want to communicate with device 2 at the same time, it will not happen. So you need some kind of protocol, some kind of rules and standards, so that if both devices have conflict, so they should be able to resolve this conflict and able to decide, okay, when and how long the device is allowed to communicate with the other device. So this is about flow control. Next we have, this is an example of the internet. So this is how our internet works. You have a local area network, and in this local area network you have an Ethernet switch which is connected to some computers and some other devices, and then this switch is connected to a router which is connected to a wide area network. Okay, and this wide area connected network is connected to another maybe local area network. So all these local area networks here they are connected to a wide area network, and then wide area network is connected to maybe a mainframe or some server with a router. So this is how your internet works. So you have a local area networks, and then a wide area networks, and then collection of all these by using routers makes the internet. So as you can see, you need, if this computer want to let's say this computer want to get some information from this server. Let's say this is from this server. So what it has to do, it has to make a communication protocol that follows all these steps, okay, to make for an efficient and reliable communication. So it has to first find out, okay, what type of network I am connected to. Is it a local area network or is it a wide area network? And then it has to decide, okay, what is the communication medium they're using, wired or wireless, because sometimes it's not always wired. Sometimes it may be a wireless connection also, okay. Maybe a wireless connection. So then it has to send data, and it must has to know the address of this server, and then ask for send data to the server. So first it go to switch, and switch will send data to router will send data to this wide area network router, and then each router knows that where is this device is located. So each router will send this data to the corresponding node, and then your this data request will arrive here, and then this server will again send this data back. So you know that there's a lot of exchange of messages required, so you also need a very efficient path for that. So these all of these you need some kind of you need to design some kind of standards that satisfies all these communication tasks. So to solve these problems, actually the problems that we have seen, because network communication, have you seen, there are a lot of tasks that we need to perform, and to satisfy all these things during communication we need some kind of protocol. Okay, we need protocol, peer-to-peer communication. For example, the communication between your device and for a computer and the printer, if it's directly connected, it's not that hard actually. But communication over the networks, this requires very efficient protocols. So why we need protocol actually? A protocol is a set of rules or conventions that allow peer layers to communicate, to transfer data. Several tasks are performed. For example, the source must activate the communication path or inform network of destination. Second one is the source must make sure that destination is prepared to receive data. So this is also So the first is to activate the communication path and or inform the network of destination. So here, for example, if this computer want to communicate with this server, so it has to first inform this network that I want to communicate, and the source make sure that the destination is prepared to receive data, and make sure that this is ready to receive data. For example, if it's already busy with some other tasks, so then your data will lost. The file transfer application on the source must confirm file management program at the destination is prepared to accept and store the file. So again, whatever you want to transfer, you have to make sure that here this is ready to actually receive the file also and store it also, because otherwise if you keep sending data and this server is not storing anything, then there is this will be a useless. A format translation function may need to be performed if the formats on the system differ. So it can happen, sometimes it can happen that here this computer may be using a different kind of protocols or different kind of maybe strategy for communication, and here they have a different, or maybe a difference in speed or different in architecture. So once it sends some data, so this network here, it must be able to actually translate this information into understandable commands, okay, that is understandable by this network here. So you need also this kind of translation. Okay, so now we have done with this, and let's see about network topology. Network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. Think of your network as a city and the topology as a roadmap. Just as there are many ways to arrange and maintain a city for getting the most traffic, there are several ways to arrange a network. Each has advantages and disadvantages, and depending on the needs of your company, certain arrangements can give you a greater degree of connectivity and security. There are two approaches to network topology: physical and logical. Physical network topology, as the name suggests, refers to the physical connection and interconnections between nodes and the networks, the wire cables, and so forth. Logical network topology is a little more abstract and strategic, referring to the conceptual understanding of how and why the network is arranged, and why it is, and how data moves through it. Okay, the first one is the bus topology. The bus topology is designed in such a way that all the stations are connected through a single cable known as backbone cable. Each node is either connected to the backbone cable by drop cable or directly connected to the backbone cable. As you can see here in this figure, so this is the bus topology, and so here you have the backbone cable, this one, and each device, it is connected to the backbone cable. When a node wants to send a message over the network, it puts a message over the network. All the stations available in the network will receive the message whether it has been addressed or not. So let's say if this device this is a sender, and what it will do, it will just put a message, and this message will be available to all the devices even if they don't want to receive it. The bus topology is mainly used in 802.3 Ethernet and 802.4 standard networks. So these are the main users of the bus topology. So here you can see that the main advantage, what I see, that it's you only need one single wire here. This is the main advantage of this. The configuration of bus topology is quite simpler as compared to other topologies. The backbone cable is considered as a single lane through which the message is broadcast to all the stations. So what I see here advantage is that there is a reduction of the number of cables that otherwise if you want to connect like 4 computers and they want to communicate with each other, then it might be more complex, but this is very organized and simple one, bus topology. Okay, now the problem here with these kind of topologies is that when actual communication happens, so then the problems arises. For example, if these two devices want to communicate not with each other but with a third device at the same time, then there is a chance that there is a collision of data. So to avoid this problem, so we use this some kind of special techniques, and we follow some protocols for that. The most common access method of bus topologies is CSMA, which stands for Carrier Sense Multiple Access. CSMA, it is a media access control used to control the data flow so that data integrity is maintained. For example, the packets do not get lost. There are two alternative ways of handling the problem that occur when two nodes send the message simultaneously. CSMA-CD, which stands for Carrier Sense Multiple Access with collision detection. So it is an access method used to detect the collision. Once the collision is detected, the sender will stop transmitting the data. Therefore, it works on recovery after the collision. The second one is the CSMA-CA, where CA stands for collision avoidance. It is an access method used to avoid the collision by checking whether the transmission media is busy or not. If busy, then the sender waits until the media becomes idle. This technique effectively reduces the possibility of collision. It does not work on recovery after the collision. So, what are the advantages of bus topology? As one, we have already seen that reduced number of wires. So, first one is low cost cable. In bus topology, nodes are directly connected to the cable without passing through a hub. Therefore, the initial cost of installation is low. The second advantage is moderate data speeds. Coaxial or twisted pair cables are mainly used in bus-based networks that supports up to 10 megabits per second. Third one is the familiar technology. Bus topology is a familiar technology as the installation and troubleshooting techniques are well known. The hardware components are easily available. And next we have limited failure. A failure is one node will not have any effect on the other nodes. This is, I guess this is one of the biggest advantages of the bus topology. Even if one of your nodes fails here, so if this one gets failed, then the other one will keep working and can keep communicating. So now see what are the disadvantages. The disadvantages of bus topology are extensive cabling. A bus topology is quite simpler, but still it requires a lot of cabling. Okay, this one, okay, maybe it's talking about maybe some comparative, but for me we have less cables here. If you see the, so for the other one, for example a ring one, here we have 1 2 3 4 5. So you have 1 2 3 4 and 5. So here that maybe it's relatively as compared to other networks is talking about, but it is simple, but it says that a lot of cabling is required. Okay, as compared to other networks, for example maybe wireless network, if you say that, yeah, as compared to wireless network there are a lot of cables, but generally speaking it is quite simple, so relatively less cables. So this one is, for me it's a little bit doubtful, because in my point of view it should be advantage. Okay, let's go to the second one, difficult troubleshooting. It requires specialized test equipment to determine the cable faults. If any fault occurs in the cable, then it would disrupt the communication for all the nodes. Okay, so here comes a problem. Now we have seen the advantage that if one node fails, let's say this one fails, so then actually the other will keep working. But if the cable fails here, then actually these two will keep working, but they cannot actually communicate with the other devices. So this is one of the disadvantage, having one single path. This is a disadvantage. Okay, signal interference. If two nodes send the message simultaneously, then the signals of both the nodes collide with each other. That's an advantage. Disadvantage, reconfiguration difficult. Adding new devices to the network would slow down the network. Okay, because you're using the same cable, backbone cable, so more number of nodes, more number of devices, more number of computers mean there will be slow communication. Attenuation. Attenuation is a loss of signal leads to communication issues. Repeaters are used to regenerate the signal. So I think this is pretty common in most of the devices, but here if the length of the cable is very long, so you need actually some kind of here repeater. Okay, for the small number of PCs it's okay, maybe they work, but for large number of devices, let's say in hundreds, this cable will be long, and then you need some kind of repeating devices. So this is disadvantages. Now quickly move to the ring topology. This is another method for connecting your devices. Ring topology is like a bus topology, but with connected ends. The nodes that receive the message from the previous computer will retransmit to the next node. The data flows in one direction. It is unidirectional. The data flows in a single loop continuously, known as endless loop. So you can see the picture of this. Okay, so the PCs, you can see they're connected in a ring, so they are interconnected, and it has no terminated ends. Each node is connected to other node and having no termination point. The data in a ring topology flow in a clockwise direction. Okay, so the data will flow like this way in a clockwise direction. And so what we can predict from here, that what I can see, that any message that is going to deliver from, let's say this is the source, this is the receiver here, so it has to pass from these two computers also, so they must be turned on, otherwise your data is not going to pass. So that's the what I see here problem, and I hope that this will be also a disadvantage. So the most common access method for ring topology is token passing. Token passing method we shall discuss here in the medium access methods. Yeah, token ring method. But for now, just remember that this topology uses token passing. It is a network access method in which token is passed from one node to another node. Token, it is a frame that circulates around the network. So for now, you just I think why not we just study it here, token ring. Okay, we can study it here, and then again maybe we repeat it there. So in token passing, how it works, a token moves around the network and it is passed from computer to computer until it reaches the destination. The sender modifies a token by putting the address along with the data. The data is passed from one device to another device until the destination address matches. Once the token received by the destination device, then it sends the acknowledgement to the sender. In a ring topology, a token is used as a carrier. So this type of topology, it solves the problem of collision, okay? Because there are multiple computers, multiple devices, so collision may happen if we don't follow any specific strategy. For example, this PC and this computer, they both want to communicate at the same time simultaneously. So then it's a problem, because let's say this wants to communicate with this PC and this also wants to communicate with this PC. So then it's a problem actually. So there is a chance that the data will be lost or it will become corrupt. So what happens is that we use here a token. So token is, as we have seen here, it is a frame that circulates around the network. It's kind of like a stamp. It's a permission to speak. It's a permission to communicate. So whichever device has this token, this is allowed to communicate. So whenever this PC will initiate, let's say this want to send data to here, this PC, so it will start with the, it will wait for a token. Once that token arrives, okay, it will write down the address of this PC, and then it will transfer this token along with the data to the next PC. Now this PC has a token, and now this PC can actually communicate, and this will transfer the token to the next PC along with the data, and then finally your token and the data will arrive here. And once that the data reach to the destination, so the token passing will then here stop, and then signal will be sent to the sender that your data has been received by the receiver. So this is how token passing works. So the advantages of these kinds of topology is that network management. Faulty devices can be removed from the network without bringing the network down. So if one of your device fails, you can just remove this device, and then for example this device fails, you can remove it and then directly connect the cable from this to this PC. Okay, this is. So the second one is the product availability. Many hardware and software tools for network operation and monitoring are available. Third one is the cost. Twisted pair cables is inexpensive and easily available. Therefore, the installation cost is very low. The fourth one is the reliability. It is more reliable network because communication systems is not dependent on the single host computer. So this is again a comparative statement, because there are some methods of communication. There are some topologies where one is the master computer, and there if the master fails then everything fails. But here you have not like this. You have many nodes, many computers, and so not a single one is managing the communication. Okay, there is no master node or master computer. So there are also some disadvantages, and one of them is difficult troubleshooting. It requires specialized test equipment to determine the cable faults. If any fault occur in the cable, then it would disrupt the communication for all the nodes. Okay, it's the same problem that we have with the bus topology. If problem happen with the backbone cable. Second disadvantage is the failure. The breakdown in one station leads to the failure of overall network. Actually, this is quite contrast, because here we have said that faulty devices can be removed from the network without bringing the network down. Okay, this is about both statements. They are true in their own scenarios. They are specific to so first, if a failure happens, okay, if a device failed, then this is for sure communication. For that instant, communication is not possible. Okay, if let's say this PC fails, then for that moment there is no communication option. But the advantage is, so this was a disadvantage. If one node fails, there is no communication. This was disadvantage. So but there is advantage is that the faulty devices can be removed from the network without bringing the network down. So once you remove this device, okay, once you remove it and connect the cable directly from here to here, and so it's quite easy. You don't need you don't need to change the whole network topology. Okay, but in some cases, for example, where there are master computers available, if your master fails, then you need to actually made a lot of changes for that. Okay, reconfiguration difficult. Adding new devices to the network would slow down the network. So again, the more computers you have, the more it will become, I would say, this ring will become larger, and of course it will take more time to communicate. Communication delays is directly proportional to the number of nodes. Adding new nodes increases the communication delay. So that was true for bus topology also, and here also, because you are using single wire for communication, so more nodes means there will be more delay in the communication. Okay, so here we have studied two network topologies, and there are some more. And let's see this network topology, third one, which is star topology. Here's how it looks like. Okay, star topology is arrangement of a network in which every node is connected to the central hub, switch, or a central computer, like shown here in the figure. So these are the nodes, computers. They're connected to a central hub that connects them. The central computer is known as server, and the peripheral devices attached to the server are known as clients. So this is server, and these are clients. Coaxial cable or RJ45 cables are used to connect the computers. Hubs or switches are mainly used as connection devices in a physical star topology. Star topology is the most popular topology in the network implementation. So this is the most popular one. I guess in our local area network, that at homes, I guess it's star topology that we use, because we have one router where there are multiple computers are connected, and you can actually communicate with them. Yeah, so it's a star topology. So what are the advantages and disadvantages of this kind of topology? So the first one is efficient troubleshooting. This is an advantage. Troubleshooting is quite efficient in a star topology as compared to bus topology. In a bus topology, the manager has to inspect the kilometers of cable. In a star topology, all the stations are connected to a centralized network. Therefore, the network administrator has to go to the single station to troubleshoot the problem. The second one is network control. Complex network control features can be easily implemented in the star topology. Any changes made in the star topology are automatically accommodated. Third is the limited failure. As each station is connected to a central hub with its own cable, therefore failure is in one cable will not affect the entire network. Familiar technology. Star topology is familiar technology as its tools are cost effective. And then we have easily expandable. It is easily expandable as new stations can be added to the open ports on the hub. Cost effectiveness. Star topology networks are cost effective as it uses inexpensive coaxial cable. And finally, we have high data speeds. It supports a bandwidth of approximately 100 MBs. That's, I think, 10 times more than was it bus topology? Yes, so it was bus topology. It was 10 MB, and here we have 100. So this is clearly a very big advantage. Ethernet 100 base T is one of the most popular star topology networks. So both these star topology and bus topology, they can be used with the Ethernet. So now the disadvantages of the star topology are a central point of failure. As it's clear from here that if a central hub or the switch goes down, then all the connected nodes will not be able to communicate with each other. So if the server goes down or the switch goes down, then no communication. On the other hand, if one node is faulty, then your network will still able to work. Second disadvantage is sometimes cable routing becomes difficult when a significant amount of routing is required. More number of nodes mean more wires and complexity will increase. The fourth type of topology that we have is, we call it tree topology. So what is a tree topology? This is its diagram here. So it says that a tree topology combines the characteristics of bus topology and star topology. So you have star topology and you combine it with the bus topology, like this. We have here the cable which was a backbone cable, and what you get is a tree topology. So notice that here, this is your server here, as we have studied in the star topology. So you have one server and these are the clients, and then again you have this second server with its own clients, and they are connected by a backbone cable that is used in the bus topology. A tree topology is a type of structure in which all the computers are connected with each other in hierarchical fashion. The topmost node in the tree topology is known as a root node, and all other nodes are the descendants of the root node. So this is, you call it the just wait a moment, I think, was it mesh? Second one is, yeah. There is only one path exists between two nodes for data transmission. Thus, it forms a parent-child hierarchy. So the advantages of tree topology are, the first one is the support for broadband transmission. Tree topology is mainly used to provide broadband transmission. For example, signals are sent over long distances without being attenuated. The second one is easily expandable. We can add the new device to the existing network, therefore we can say that tree topology is easily expandable. Then it is easily manageable also. In the tree topology, the whole network is divided into segments known as star networks, which can be easily managed and maintained. Error detection and error correction are very easy in tree topology. And limited failure, the breakdown in one station does not affect the entire network, and it has point-to-point wiring for individual segments. So these are some advantages, and if you see the disadvantages, then we have here It's difficult troubleshooting. If any fault occurs in the node, then it becomes difficult to troubleshoot the problem. It has high cost. Devices required for broadband transmission are very costly. Failure tree topology mainly relies on main bus cable, and failure in main bus cable will damage the overall network. Reconfiguration difficult. If new devices are added, then it becomes difficult to reconfigure. So these were some advantages and disadvantages of the tree topology. And now let's quickly move for the mesh topology. Mesh topology, as you can see in this figure here, this is like in here, devices are connected, and not only in a ring fashion, but also there is also interconnection between multiple devices. Mesh topology is an arrangement of the network in which computers are interconnected with each other through various redundant connections. There are multiple paths from one computer to another computer. It does not contain the switch, hub, or any central computer, which acts as a central point of communication. The internet is an example of mesh topology. This is important. So the internet, this is actually example of mesh topology, but previously I guess I said this for star topology. Well, this I have to look for that again, because theoretically it looks like our computers are connected like this way. We have a central hub or switch, and then our devices are connected. But this is also one way of connecting the internet devices, where devices are connected. Mesh topology is mainly used for wide area network implementations where communication failures are a critical concern. So wide area network, this is wide area network. Mesh topology is mainly used for wireless networks. Okay, so in wireless networks things are connected like in this way, especially for example the okay, I'm not sure about this Bluetooth devices. They are also, they don't form a network actually, the Bluetooth devices. So the wide area network that we have studied here in the previous slide was here somewhere. So here the wide area network, you see that here we have the devices that are connected to a switch, and then this is connected to wide area network, but there is no direct connection here. Mesh topology is mainly used for wide area network implementations where communication failures are a critical concern. Okay, where there is a fear of failure actually, where it's very important that your system should not be fail proof actually. So there we can use this mesh topology in a wide area network. Otherwise you can also use other topologies, for example star topology, but this one I will make sure again. Okay, so advantages of mesh topology are this: it is reliable. The mesh topology networks are very reliable, as if any link breakdown will not affect the communication between connected computers. So let's say if this link breakdowns, even then you have communication possible, because there are multiple routes, multiple paths for communication. And fast communication is very fast between the nodes, easier reconfiguration. Adding new nodes, new devices would not disrupt the communication between other devices, because all of this is because you have multiple paths, and also the shortest paths also. For example, if this computer want to send data to this computer here, so it can send by this path, or it can also directly send by this path. So you need some kind of routing protocol that finds the shortest path in this graph, in this topology, and it sends packets of data directly from here to this computer instead of following the longest route or even the much longer route here. So yeah, from here I can say that this happens in internet also much often, where you have to send data from one PC to another. You need to find actually the shortest route. Okay, so now the disadvantages is the cost. Mesh topology contains a large number of connected devices such as a router and more transmission media than other topologies. Management. Mesh topology networks are very large and very difficult to maintain and manage. If the network is not monitored carefully, then the communication link failure goes undetected. And finally, we have efficiency. In this topology, redundant connections are high. That reduces the efficiency of the network. So these were some advantages and disadvantages. And now, so our next topic is medium access methods or communication methods we have. And there are three methods for communication between networks. So in this method, what we want to do, we want to set some rules that how the participants of the communication are allowed to communicate with each other. For example, if there are multiple partners, if there are multiple devices in a network, so we have to make some rules and standards so that they can communicate on their in their turn, and the communication is without any collisions, because if multiple devices want to communicate at the same time, then there can be problems. So in these medium access methods, we have three different types of methods in which devices are allowed to access the communication medium. Okay, the first one is a master slave, second is a token ring, and third one is random access. So in a master slave communication, first of all, it is quite simple one, because we have not much. You have a master and couple of slave devices, and it's also used for industrial controllers. In this technique, a master device issues commands to one or more slaves, and the slave respond. Okay, so here for example, in this figure, you see the master is the entity which grants access to the medium. Okay, so the master is actually the boss, and if there are multiple devices, so this master will allow the other devices, the slave devices, to speak, okay, or to communicate. So this is the responsibility of the master node. And the slave is the entity which accesses the medium after requesting it from the master. So whenever any slave device wants to communicate, wants to send data, so what it need to do, it need to first ask the master, and if the master allows this device, then it is then it may communicate. Okay, so this is how the communication works. You have a master device here, and it will ask the slave device using polling. It will say, what do you want to say? And the slave can respond like, I don't want to communicate, or it can say, okay, I want to communicate and please allow me access, and then master will allow this device the access. It seems like in a classroom, the students, if they want to communicate, they have to ask the teacher, and in this case the teacher is the master, and the students first raises his hand and asks for the permission to the teacher that may I ask a question, and the teacher says, okay, you can ask. Then they can allow to communicate. Otherwise they are supposed to sit quietly in a classroom. The example of this is master slave communication is a Profibus DP. This is a communication protocol which uses master slave method for medium access. The second method is token ring. Token ring networks rely on token passing for data communications. As the name suggests, token ring communications is used on ring networks. A special message called the token is passed from one machine to another around the ring, and each machine can transmit only while it is holding the token. Token ring networks never became prevalent in business and industry. However, token passing doesn't require a ring network for use. It can be and is used on networks for other topologies. So some protocols rely on token passing but don't use a ring network. So as you can see in this figure, we have already discussed this token passing in the previous slide. The members of the logical ring gain access to the network upon receipt of a token. The token is a group of bits that is passed in a rotating address sequence from one node to another. So as we already studied in the previous slide, that whoever has a token, so let's say this is a you have a token, some kind of token, and what is it's actually a digital group of bits, and whoever have this token, this is allowed to communicate. Now address 2 has the token and it can communicate, and then the token will be passed to the second device, and now this device is allowed to communicate, and similarly in a turn by turn, every device is will be given a chance to communicate. The example of token ring type of communication or medium access method is used in Modbus Plus. So this is again a protocol, communication protocol that is widely used. And the third one is the random access. This is note that here in the previous two methods what we have studied, that the medium access method was not random. Okay, it was known that who is allowed to communicate and who is not. For example, in master slave, it can be predictable that who will be the communicator. Okay, and if for example, if the multiple devices want to communicate at the same time, the master can set a priority that which device should communicate first. And same is true for here. For the token ring, we can predict that first this device will communicate, then next device will be here, and then third, and then fourth. But in the random access method, the things are not predictable. Okay, Ethernet is essentially a method for communication between computers and other devices on a network. Ethernet makes use of carrier sense multiple access with collision detection, or CSMA-CD. On an Ethernet network, any node can communicate with any other node. It works like this. First, before a computer or controller sends data to another or more than one device, it listens to see if the network is busy. If the network is active, it will wait and try to send data later. If it senses the network is available, it will transmit the data. However, due to network time delays, a node may start sending data before it senses data released by another network node. In that case, a data collision occurs, and neither node will be able to successfully transmit data. Afterwards, each device will wait a random amount of time before attempting data transfer again. Ethernet works better than any other method for large networks. That's why Internet uses Ethernet. And use of Ethernet method has become common among industrial controllers. Furthermore, communication speeds on Ethernet networks are fast. So this random access method is it uses carrier sense multiple access, a set of rules determining how network devices respond when two devices attempt to use the medium simultaneously, called a collision. Okay, when two devices they simultaneously want to communicate, then there is a collision. CSMA-CD is a type of contention protocol, competition for resources. Informal discussion between undisciplined individuals. As soon as there's a silence, the one who wants to talk begins to speak. So that's why it's random, because there is no discipline, there is no turn. It's like a group of friends, okay, and you cannot predict that who will gonna talk again. It's like a random. Two-person can whenever they find a silence, let's say people were talking and then there is a silence, and then somebody again started talking, and if there two devices started talking at the same time, then there is a collision. Okay, and there are ways for collision detection, and also there are some methods for collision avoidance also. Okay, so our next topic is the OSI model, and OSI stands for Open System Interconnection, and OSI model describes 7 layers that computer systems use to communicate over a network. It was the first standard model for network communications, adopted by all major computer and telecommunication companies in the early 1980s. The modern internet is not based on OSI but on the simpler TCP/IP model. However, the OSI 7-layer model is still widely used, as it helps visualize and communicate how networks operate and helps isolate and troubleshoot networking problems. OSI was introduced in 1983 by representatives of the major computer and telecom companies and was adopted by ISO as an international standard in 1984. So these are the 7 layers of the OSI model for communication. So when two devices needs to communicate, they must follow this model for better, efficient, and for proper communication. Okay, and these are the 7 layers. We have the first layer is application layer, then we have data link layer. The first one is the physical layer, and then we have data link layer, network layer, transport layer, session layer, presentation layer, application layer. Okay, and let's see one by one what are their functions. So starting from from the end, the application layer. The application layer is used by end user software such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to users. A few examples of application layer protocols are Hypertext Transfer Protocol, HTTP, File Transfer Protocol, which is FTP, Post Office Protocol, Simple Mail Transfer Protocol, and Domain Name System. So these all protocols are present in the application layer. Then we have layer number 6, which is a presentation layer. The presentation layer prepares data for the application layer. It defines how two devices should encode, encrypt, and compress data so it is received correctly on the other end. The presentation layer takes any data transmitted by the application layer and prepares it for the transmission over the session layer. Number 5th is the session layer. The session layer creates communication channels called sessions between devices. It is responsible for opening sessions, ensuring that they remain open and functional while data is being transferred, and closing them when communication ends. The session layer can also set checkpoints during the data transfer. If the session is interrupted, devices can resume data transfer from the last checkpoint. Number 4th is the transport layer. The transport layer takes data transferred in the session layer and breaks it into segments on the transmitting end. It is responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer. The transport layer carries out flow control, sending data at the rate that matches the connection speed of the receiving device. The error control, checking if the data was received incorrectly, and if not, requesting it again. And then we have number 3, which is the network layer. The network layer has 2 main functions. One is breaking up segments into network packets and reassembling the packets on the receiving end. The other is routing packets by discovering the best path across the physical network. The network layer uses network addresses, typically internet protocol addresses, to route packets to the destination node. So this is the you remember in any network there are multiple nodes, especially in the mesh topology. We have seen that there are multiple paths to reach the receiver or to the destination. So in the network layer, so it's one of its function is to route the packages. You have to find the shortest path or efficient path for data transfer. Then you have the second one is the data link layer. The data link layer establishes and terminates a connection between 2 physically connected nodes on a network. It breaks up packets into frames and sends them from source to destination. This layer is composed of 2 parts: logical link control, which identifies network protocols, performs error checking, and synchronizes frames. The second part is media access control, which uses MAC addresses to connect devices and define permissions to transmit and receive data. Okay, and then we have the first layer. The physical layer is responsible for the physical cable or wireless connection between network nodes. It defines the connector, the electrical cable or wireless technology connecting the devices, and is responsible for transmission of raw data, which is simply a series of zeros and ones, while taking care of bit rate control. So these are the layers, OSI layers for the communication, and each layer has its own functions. Not all the protocols use these layers, and some of them just skip some layers. For example, this TCP IP model, it does not use actually all the layers. Instead, it simplifies by combining some layers into a single layer. So yeah, so what are the advantages why we use OSI model? The OSI model helps user and operators of computer networks to determine the required hardware and software to build their network, understand and communicate the process followed by components communicating across the network, perform troubleshooting by identifying which network layer is causing an issue and focusing efforts on that layer. So these are some advantages, and as we have already discussed, that the transfer control protocol or internet protocol, which is TCP IP, is older than OSI model and was created by US Department of Defense. And the difference between them, these models is that TCP IP is simpler, collapsing several OSI layers into one. So the things were made simpler in TCP IP protocol. So yeah, so we this is the end of our lecture, and thank you very much. If you have any questions, you can contact me by email.